Hey everyone, so if you didn't know, most people that have studied Stan's work already do know this, but he actually used water as an electrical component in the circuit in two different ways. He used it as a dielectric medium, but he also used it for its resistance properties. Water is not a perfect conductor. So, we'll look at his technical brief here on page 1-1. Water now becomes part of the VIC in the form of resistance. Now here on page 3-8, water now becomes part of the VIC in the form of resistance between 67 and 66 of figure 3-22. Here's figure 3-22. You can see 67 and 66, the electrodes. Stan calls them the voltage zones, but he's saying that the resistance occurs between them. Now here's his equation for the total resistance of the secondary circuit. I've rewritten it. So resistance total equals secondary coil resistance plus the L1 choke and L2 choke resistances plus RE, which he says is the resistance of water. So still in the tech brief, page 7-11, RE is the dielectric property of water and its resistive value. And again on page 7-15, he says water resistance RE. So if you're trying to measure the resistance of the cell, this is tap water in here right now, with just a normal digital multimeter, you'll never get the correct measurement. It's just going to bounce around all over. Yeah, you'll never get a good measurement out of that. It's not going to be accurate at all, so I'll show you what I use. Okay, so this is a DE 5000 meter. Bought it online. You look them up, you'll find them. I think they're about $100. Might be cheaper now. But it measures resistance and it measures at a different frequencies. So here at 1 kilohertz, I'm getting 152 ohms for the 6-cell unit. If I change that to 10 kilohertz, I get 132 ohms. So you could say, roughly 140 ohms for the 6-cell unit. Now we'll look at a little bit of math. Okay, so 140 ohms divided by my 6 cells gives me 23.3 ohms per cell. Now you can see that's one reason why Stan connected them all in series. If you know electronics, you know resistance is in series. The total resistance is a sum of all of them together. So the total secondary resistance is the secondary coil resistance plus the choke resistances plus RE, which is the resistance of the water. Now in this case, I'm using tap water. If I use ocean water, it's going to be more conductive. Also, maybe a higher temperature tap water, it will also get more conductive as well. That poses a problem. If you do the math, you find Stan in his 11-cell unit developed that so the minimum resistance per cell was about 28 ohms. And you get below that and your transformer voltage regulation starts to drop off. So we'll see what he did to combat that. So in the tech brief on page 3-24, he says he uses an electrostatic water filter. Suspend and dissolve water contaminants, blah, 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 deposited inside the electrostatic water filter. And we'll look at the diagram and then some pictures of it. Alright, there's the diagram. Now let's find some pictures. Okay, there's a couple different pictures coming out of the bottom of the cell there. And another one. So, that's it for now. Thanks for watching, guys. Take care.